This image right here gets to the heart of it. Insomnia isn't a passive failure to get tired. It's an active, fierce battle that's being lost night after night. And the core of this whole thing is what we're going to call the cerebral seesaw. On one side, you have sleep. On the other, wakefulness. And for someone with insomnia, that seesaw is just brutally stuck on one side.
So, first, let's just completely bust the biggest myth about sleep. We hear it all the time from patients, right? I just can't switch my brain off. But what if the brain isn't a switch at all?
And this slide just lays it out perfectly. The myth is that falling asleep is like flicking off a light switch, a passive process. The reality? It is the complete opposite. To fall asleep, your brain has to actively turn on a powerful system that's designed to literally force silence on another equally powerful system. It's a neurological clash of titans every single night.
So this brings us to the battlefield itself. Who are these two armies fighting for control of your consciousness? Let's meet the teams.
On one side of our seesaw, we've got team wakefulness. Its champions are some key neurotransmitters you might know. You've got histamine, yep, the same one from allergies, which is a super powerful alerting agent in the brain. And you've got orexin, a major player that keeps us awake and alert. Then, on the other side, we have team sleep. Its champions are a little structure called the VLPO and its secret weapon, GABA, which is basically the brain's main brake pedal.
Now, this system is what we call a flip-flop switch. What does that mean? It means it can only be in one state at a time. You're either fully awake or you're fully asleep. There's no middle ground. One team has to dominate the other, and this is exactly why insomnia can feel so absolute. The switch is literally stuck in the on position.
And this slide really nails the mechanism. It's all about reciprocal inhibition. When Team Sleep wins, it doesn't just politely ask Team Wakefulness to quiet down. It actively crushes it. And when Team Wakefulness is in charge, it does the exact same thing to the sleep centers. One has to totally suppress the other to take command.
So, how does Team Sleep actually win this battle? Well, it's not random. There's a precise, beautifully orchestrated sequence of events. Let's break it down, step by step.
The first shot isn't fired by chance. It's triggered by a universal signal, darkness. When your eyes sense that the light is gone, it sends a message to your pineal gland to produce the first soldier for Team Sleep, that chemical messenger, melatonin. Its job is to prepare the battlefield.
Think of it this way. During the day, your brain's master clock, the suprachiasmatic nucleus, or SCN, is like a watchman constantly shouting, "It's daytime! Stay awake! Stay awake!" Melatonin is the gag. As night falls, melatonin is released, it binds to the SCN, and it forces it into silence. Only when this loud watchman is finally quieted can the real sleep offensive begin.
But wait, this brings up a really crucial question. If melatonin just silences the daytime guard, who's the actual general that leads the charge and flips that master switch to off?
Meet the true leader of Team Sleep. You need to remember this name, the ventrolateral preoptic nucleus, or VLPO. This tiny cluster of neurons is the fundamental off switch for your conscious mind. Once that SCN is silenced, the VLPO is finally unleashed.
So how does the VLPO actually do it? How does it flip the switch? Well, it uses a powerful secret weapon. Once the SCN's daytime signal is gone, the VLPO is free to activate. It then unleashes a massive flood of that inhibitory neurotransmitter, GABA. And this GABA acts like a tranquilizer, binding to all those arousal centers and basically anesthetizing team wakefulness. This is the final move that dramatically tips our seesaw over to the side of sleep.
But Team Wakefulness does not go down without a fight. Its champions, Histamine and Orexin, have a pretty aggressive dual mission. They don't just stimulate the cortex to keep you alert, they also launch a direct counterattack, sending inhibitory signals right back at the VLPO, actively trying to stop it from ever pressing that off switch. It's a constant struggle for control.
Okay, so now you get the normal mechanism. So what goes wrong in an insomniac? What happens when this delicate, beautiful seesaw gets jammed?
We can trace this failure back to two main scenarios. In the first one, Team Sleep is just too weak. It's like its battery is depleted. It can't generate enough inhibitory force to tip the seesaw. We call this an inhibition defect. In the second scenario, the problem isn't a weak sleep system at all. It's a hyperactive wakefulness system. It's basically on steroids, and it's become too heavy for the seesaw. We call this an activation excess.
And this gives us a simple but really powerful framework. Not all insomnia is the same. There are two very distinct types, based entirely on which side of the seesaw is failing. And understanding this difference, well, that's the key to actually treating it effectively. Let's just break this down side by side. In type 1, the inhibition defect, the problem is not enough melatonin or GABA. Team sleep is just too weak, so the VLPO can't impose silence. What's the analogy? It's like the car has no brakes. Now, in type 2, activation excess, the problem is too much histamine or orexin. Team wakefulness is way too strong and it's crushing the VLPO. Here, the analogy is that the engine is stuck at full throttle. So understanding these two types of failure is everything, because if we know why the seesaw is broken, we can start to figure out how to repair it.
The therapeutic logic now becomes crystal clear. Our job when we're helping our patients is simply to rebalance this seesaw. But here's the trap. What doctors often don't explain is why a sleeping pill can be a total miracle for one patient and do absolutely nothing for another.
Well, the answer lies in the choice of weapons. Are we trying to boost the weak team sleep, or are we trying to suppress the hyperactive team wakefulness? The strategy depends entirely on which side of the seesaw we need to target, and that is a cliffhanger we are going to explore in our next explainer on pharmacology. But before we go, let's quickly test what you've learned. First question, what is the principal role of the VLPO? The answer is B, it inhibits wakefulness using GABA. Next up, orexin is a molecule that C, maintains wakefulness. And finally, a quick flash case. A patient with very high cerebral histamine has insomnia. Is this due to B, an activation excess? Excellent work, everyone.
So here's the most important takeaway from all of this. From this moment on, you won't just see sleep as a passive state of rest. You'll see the battle. You'll see the nightly victory that has to be won. And your job is to understand that battlefield so you can give your patients the right tools to win their fight for sleep.
Before we go, I've got a question for you. Which analogy really clicked for you and helped you understand the mechanism? Was it the seesaw, the watchman, or the master switch? Let us know down in the comments. Now that you understand the battlefield, join us in our next explainer where we are going to discuss the weapons we use to win the fight for sleep.